Good morning, everyone. Welcome to today's lecture on measuring resistance. Resistance measured in ohms is a key factor in understanding how current flows through a component or a circuit section. We will cover how to use an ohm meter effectively, interpret readings, and apply these principles in practical examples. Now, an ohm meter measures the resistance in a circuit by applying a small voltage through its lead. It works only when there is no current flowing in the circuit. For example, if you are testing a light bulb, an ohm meter measures the resistance of the bulb filament, helping us in determining if filament is intact or broken. Now see, this is a bulb and this ohm meter is used to measure the resistance of this filament. Now coming on to the next important concept, that is understanding this 0 and infinity readings. 0 ohms means there is no resistance, indicating a continuous path. If an infinity or over limit regarding means the circuit is open with no path for current. For instance, if you test a wire and get 0 ohm, it indicates it's intact. If it shows OL, there is a break somewhere and the current will not get a complete path to flow. Let's look into the schematic as shown in this slide. A multimeter is used. So here we have used probes. The probes are connected as shown by 1. The second step indicates that we have to set the multimeter knob to pointing towards ohm or resistance. And third is you have to connect or we have to touch the probes with each other. So using this method, you can test whether the multimeter operation is in proper way or not. If there is a continuity, the multimeter will give us a beep indicating continuous circuit. There is one more feature that is called as a auto ranging in some advanced multimeters. This auto ranging feature indicates or give us the value, okay, automatically without any necessity of selecting a range by moving the knob. In this diagram, this is a summary of a multimeter for measuring a particular circuit. Here, if I want to check the volt, I have to connect this multimeter in a parallel. If I want to check the current flow through the circuit, I want to connect this multimeter in series. If I want to check a resistance or the voltage drop across a load, then I have to connect this multimeter in parallel across the load. If I want to check the voltage drop across a bulb, I have to connect this voltmeter in parallel. If I want to check the resistance of this bulb, then I have to cut off the battery supply to this bulb, connect this ohm meter in parallel and measure the resistance of this bulb. Now this is an important slide. Here there is nothing but the convergence. Okay, so as you know, these electrical units are measured in volts, amperes, and ohms. For example, 1 kilovolt indicates it is around 1000 volts. Okay, 1 kilo ohm is equivalent to 1000 ohms. 1 megavolt is equivalent to 1000 kilo ohms, kilovolts. And similarly, 1 mega ohm is equivalent to 1000 kilo ohms. 1 megavolt is equivalent to 1000 kilovolts. I hope you have understood these units. Now, the another feature of the multimeter is the auto ranging feature that we have studied in the last lecture. Now, if the units of the multimeter that we have to cautiously understood whether they are in ohms, whether they are in kilo ohms or mega ohms. So in case of this auto ranging multimeter, there is we can say a special indicator provided in its display, which indicates the unit of the quantity which is being measured. So this, and if we have seen what is mega, what is kilo, but if it comes to milli, micro, okay, so I think you must be knowing that milli is nothing but a small unit. Okay, micro is also a small unit. So for example, if I want to check the milli, it is nothing but about 1 divided by 1000 of that quantity. A micro is nothing but 1 divided by 1 into 10 raised to 6 of that quantity. Okay, so now coming on to the next concepts. Okay, there are certain things that you should consider, or there are certain cautious things that you should consider while measuring the resistance in the circuit. Remember, an ohm meter applies a small voltage to measure resistance, so the component must be isolated. For example, if you are testing a sensors in a car computer system, disconnect it from the circuit. Measuring in circuit can damage the computer sensitive components due to ohm meters applied voltage. And how much voltage this ohm meter apply for measuring the resistance? The voltage is around 0.3 to 1 volt, and this voltage is quite enough, uh, or it is very high for certain sensitive components. This can damage the sensitive electronic components which are there in our automobiles. Now, next important part, as I have discussed, is the auto ranging features. Now, this auto ranging features automatically selects the appropriate scale. If you are testing a resistance that is around 2 kilo ohms, the meter will automatically display 18 kilo ohms. This feature simplify the process, but always check the units on the display to ensure the accuracy, which I have discussed earlier. So, winding today's lecture. So, coming on the summary of the today's lecture, we have seen how to measure the resistance of different components in a circuit using a multimeter. And this measuring this resistance is essential for troubleshooting and confirming circuit integrity. Using an ohm meter effectively, understanding readings, and knowing how to handle prefixes all contribute to accurate and safe electrical diagnostics. I hope you have understood today's lecture. If any students has any doubts, please feel free to drop me an email. Thank you.